Now we will see how to design digital filters by using bilinear transformation, which is called BLT. So steps involved in this is, first step, what we have to do is, from the given specifications, the same, we have to calculate its analog frequency, the transfer function HA of S we have to calculate. So then we have to calculate pre-wrapping analog frequency using the formula ohm is equal to 2 by T into tan of omega by 2. Using this we have to calculate ohm, okay, frequency in radian per second we have to calculate. And after this, second step, what we have to do is, using analog frequency, first we have to go ahead with this frequency and then we have to calculate HA of S. So after calculating this transfer function, what we have to do is express this HA of S into H of S, which is analog to a frequency domain, and then what we have to do is select the sampling rate. Okay, third step, what we have to do is select the sampling rate of a digital filter, which is T in seconds. Okay, so in seconds per sample we have to calculate. So that means we have to assume, or we can consider this point. So most of the time they will be providing this, and most of the time they will be providing this as well. So directly also they will provide this. It means directly next step is we have to apply BLT method, that is nothing but bilinear transformation, to find the H of Z. So how to calculate this? So he is just substituting S as 2 by T into 1 minus Z raised to minus 1 divided by 1 plus Z raised to minus 1. Only in the place of S we have to substitute 2 by T, 1 minus Z raised to minus 1 divided by 1 plus Z raised to minus 1. So we will see an example, then we will understand. Actually, compared to our IIT, it is easier. We will see an example. The transfer function of an analog filter is H of S is equal to 1 divided by S plus 1. Obtain the transfer function of the digital filter using bilinear transformation. Assume sampling duration of 1 second. So from this what we can get is H of S they have given directly, which is 1 by S plus 1, and digital filter using bilinear transformation method. So for T sampling duration of 1 second, means T also they have given. So for this example, H of S is equal to 1 divided by S plus 1, T is equal to 1 second. So in this case what we have to do is, everything they have provided, so what we wanted, right? So now directly we have to express or apply the technique. How to apply? H of Z will be equal to, in the place of we substitute S as 2 by T here. 1 minus Z raised to minus 1 divided by 1 plus Z raised to minus 1. In this H of Z is equal to, H of S we have this, okay, H of S is 1 divided by S plus 1. Now we will substitute S value, okay, S in the place of S, 1 divided by S, which is 2 by T into 1 minus Z raised to minus 1 divided by 1 plus Z raised to minus 1. Okay, so now we will simplify this. So T is 1 second, which is nothing but 1 divided by 2 into right, 1 minus Z raised to minus 1 divided by 1 plus Z raised to minus 1. Okay, so in this case what okay, so this is S, 1 divided by, this is S plus 1 we have, right? So 1 divided by, this in the place of S, okay, in the place of S we have substituted this value. So 1 divided by S plus 1. So this is 1 divided by S plus 1. Okay, so now what we have to do is, further is simply simplification. We will simplify this, which is equal to 1 divided by 2 as it is, 1 minus Z raised to minus 1 plus. So we will take this here and make a denominator same, which is 1 plus Z raised to minus 1 whole divided by 1 plus Z raised to minus 1. So this Z raised to minus 1 plus Z raised to minus goes to the numerator. So which is 1 plus Z raised to minus 1 goes up, and then down we have 2, means in the denominator we have 2 into 1 minus Z raised to minus 1 plus 1 plus Z raised to minus 1. So we will simplify this, which is 1 plus Z raised to minus 1 2 into 1 is 2, 2 minus 2 z raised to minus 1 plus 1 plus z raised to minus 1. We will simplify this bit more. 1 plus z raised to minus 1 as it is, divided by 2 plus 1 is 3. Okay, 2 plus 1 is 3, minus 2 z raised to minus 1 plus z raised to minus 1, which is minus z raised to minus 1, which is h of z is equal to. So this is our bilinear transformation. We'll have another example, which is now calculate design, or you can say apply BLT for the system. H of s is equal to 2 divided by s plus 1 into s plus 2. Okay, for t is equal to 2 seconds. How we can apply the bilinear transformation? As we said, it is quite easy. Just we have to substitute in the place of s by s has to be substituted by 2 by t into 1 minus z raised to minus 1 divided by 1 plus z raised to minus 1. Okay, so now we have 2 divided by this. So in the place of s we have to substitute. S is 2 divided by t into 1 minus z raised to minus 1 divided by 1 plus z raised to minus 1. Okay, so this is s. Okay, this is s plus 1. This is first term. Second term is, it is human tendency to forget this, right? Completely, once we write plus 1 we forget. Please don't do that. Even I did in the earlier case, right? So s is again 2 by t into 1 minus z raised to minus 1 divided by 1 plus z raised to minus 1. This is s plus 2. Okay. Further is simply simplification. For t is equal to 2 seconds, so we can substitute t equal to 2 here. Once you substitute t is equal to 2, so it is 2, and then this is also 2. So 2 ones are 2 to get cancel each other. So then further, as I said, to just to simplify, so it is nothing but 1 minus z raised to minus 1 divided by 1 plus z raised to minus 1 plus 1 into 1 minus z raised to minus 1 divided by 1 plus z raised to minus 1 plus 2. Okay, so this one is 2 divided by 1 minus z raised to minus 1 plus simplification 1 plus z raised to minus 1 divided by 1 plus z raised to minus 1, right? Next into 1 minus z raised to minus 1 plus 2 into 1 plus 2 z raised to minus 1 whole divided by 1 plus z raised to minus 1. So these two, 1 plus z raised to minus 1, 1 plus z raised to minus 1, these two goes up, which is 2 into 1 plus z raised to minus 1 into 1 plus z raised to minus 1. We can write as square of that, right? 2 into 1 plus z raised to minus 1 whole square divided by, so this is 1 minus z raised to minus 1 plus 1 plus z raised to minus 1. So this get cancelled, right? Which remains only 2 into, so in this case 1 plus 2, which is 3, minus z raised to minus 1 plus 2 z raised to minus 1, which is plus z raised to minus 1. Okay, 2 get cancelled. So we can write 1 plus z raised to minus 1, sorry, z raised to minus 1 whole square divided by 3 plus z raised to minus 1, which is h of z. This is bilinear transformation technique to find out or to design the digital filters. Okay, digital filters. There are two methods we have discussed to design the digital filters of Butterworth, we can say. So here we have, one is impulse invariance technique or transformation, and bilinear transformation, which is called IIT and BLT. Okay, these two are the techniques and to design the digital filters.